Assalamualaikum warahmatullahi wabarakatuh and good morning. So welcome to Digital Expert Symposium 2023. So my name is Dr. Baharudin bin Osman from School of Computing, University of Malaysia. Today I will present my paper titled Steganography, Concealment through Dark Color Scheme. Outline consists of introduction, literature review, methodology, analysis and result, and finally conclusion. In the current era of digital technology, data transmission in digital communication plays a vital role in our daily life. There are various forms of the information exchange such as text, image, audio, and video, and also the network protocol. Data communication over the internet has increased significantly, resulting in high data traffic and raising concern about the security of transmitted data. Transmission data over the internet always get an intention of the intruders, which cause the security of sensitive data, and also it is a problem and need to be preserved to prevent data leakage. The data of internet need to protect sensitive data so that the irresponsible parties cannot access it. It is a challenging to establish a trustworthy communication between two parties who share personal data. Failure to ensure that the information sent is protected can result in it being tampered with the irresponsible parties. Confidentiality and data integrity are required to protect the confidentiality of data and to ensure that the data received is not altered by the third parties. Therefore, information hiding is an alternative method that can be used to protect the data because the message sent is not only encrypted but also the existence of the message is not noticed by the intruder during the data transfer process. Krishna et al. In 2016 suggested that steganography is one of the techniques that can be used to overcome this problem where the message sent over the internet is not noticed by the intruder. So before we proceed, let's look at the definition of steganography. Steganography is the practice of concealing one piece of the information within another in order to hide its existence, whereby when we send the message or secret message in steganography, the secret message will be hide into another message, whereby the message that we send from sender to receiver will not notice by the intruder. The word steganography is derived from the Greek words steganos, meaning that cover or conceal, and the graphia meaning writing. There is a difference between steganography and cryptography, where cryptography which focus on the making the content of the message unreadable, whereby if you look, the steganography aim to make the very existence of the message undetectable, meaning that cryptography focus on unreadable data, but steganography focus on undetectable. The final process of the steganography is to get the stegotext, where sometimes there is the issue there, where the suspicious of the generated stegotext due to the significant changes of the generated stegotext. So in order to minimize the noticeable color changes to the generated stegotext, the major goal of this study is to recommend using the specific color for each red, green, and blue color, what we call it RGB color. Here are the three examples of the generated stegotext that been produced by Malik 2016 and also Malik 2016 and also by the Tabit et al. 2020. They use their different techniques in order to hide the message. Okay, the message that generated is very colorful and it is very suspicious for intruder to suspect there are something hide in the message. To overcome the previous problem, this study suggests techniques for dynamically representing a secret message based on the placement of randomly chosen character, and also using the homophonic cyber tables which generated based on the cover text. The homophonic cyber tables will be generated based on the characters on the cover text. This technique also uses what we call the second quotient remainder theorem or security to map the values of the XYZ with the RGB color in order to transform the secret message character to XYZ form. As you look in this figure as cited by Mitarajan and Rajapan 2013, information security can be divided into three, which are cryptography, steganography, and watermarking. Steganography also can be divided into two groups, which are linguistic and technical. So for technical, we have the method and cover. For cover, we have an image, audio, text. This one is the protocol, not audio. So meaning that, so we can use image as a cover text, audio as a cover text, or text as a cover text, and also as a protocol as a cover text. In this study, we focus on the text as a cover text, meaning that we use the text of secret message in form of text and hide it into the text also. This table shows the difference between cryptography, steganography, and watermarking. If you look at in terms of the definition, the cryptography is the art and science of the secret codes, whereby steganography is the process of hiding digital information in the carrier signal, meaning that we hide the secret message into another medium or another what we call the carrier signal. So in watermarking, the definition is the art and science of the hiding information. For secret message, in cryptography, it will be scrambled and in form of the unreadable data or invariable character. But in steganography, the secret message will be hide, not scrambled. But in watermarking, it is invisible or perceptual visible depending on the required. So you can see also here the in terms of the objective and also the security for these three type of the information security. So if we look on the previous example of the generated stegotext, concealing a message using color attribute can cause significant changes and produce suspicious stegotext if we use if the use of the color is not considered, meaning that you can see on the previous examples, the generated stegotext is very colorful, and if we hide the message, the secret message inside there, meaning that today or the message are suspicious to anyone. According to Rasmi and Mohana Priya 2016, an excellent steganographic method must not change the attribute or minimum changes of the cover medium. Significantly after the occurrence of the concealment process, meaning after the process of the hiding process. There are various mediums that can be used in steganography. Example, as we discussed before, we can use image, we can use text, we can use audio, you can use protocol as a medium for steganography. So why is text very important, or we choose text as in this study? If you look here, text is very popular in daily data transmission compared to the others, meaning that we use email to send the data. We use text to send an email. We also use text during chatting compared to the others. Image or audio or protocol. And also text use less memory compared to the others, and then it also use a low bandwidth compared to the others. Increasing the capacity of the secret message while the retaining visibility is the primary concern of the researcher. That's why they prefer to use the text steganography or text medium compared to the image, audio, or video. This is the steganography process. If you look here, we have the cover text here, and then we have the secret message. The secret message will be hide into the cover text, using what we call the embedding algorithm or embedding process, and the output of the process is we call a stegotext. The stegotext, okay, will be sent, okay, to the receiver using the any channels, okay, and then the receiver will receive, okay, the stegotext, and then will extract, okay, will extract the data that hide, or the secret message that hide into the stegotext to get the original secret message. Okay, this table shows the hidden message capacity based on the previous study using the RGB color. Capacity is one of the measurement that used to see the performance of the steganography. Okay, based on the previous researcher, Al-Asadi here, if you look, it only can hide 2 bits in the cover text size of 7 characters. Malik, Sika, and Verma can hide the secret message size of 198 into cover text size of 8447 characters. Same for the Malik. Okay, the technique can hide only 198 characters inside the cover text size of 847 characters. And Al-Azawi can hide the secret message size of 34 into the cover text size of 20003, 202. And also Tabit, okay, can hide the secret message size of 801 into the cover text size of 847 characters. Okay, so we can calculate, okay, calculate the hiding capacity using the percentage. The percentage show the performance of the technique that used by the previous researcher. In the proposed technique, okay, we will generate a table, what we call the homophonic table. This table is getting from the cover text that we use. Okay, example, if you look here, example, this is the character. Every character, okay, inside the cover text will be identify the location of the character, where it appear. Example, character A appear at location 6, 19, 26, 32, 47. Character B appear at location 56, 99, 100, and so forth. Okay, this is how we generate the homophonic tables. Okay, this one based on cover text. Different cover text will produce different homophonic value. This one is the step of the hiding process. Okay, we start with the creating the homophonic table, and after that, the secret message of character will convert into the 3D representation, meaning that we convert it into X, Y, Z. Okay, via the what we call the pseudo random number generator, and then after that, we will map the character to the RGB colors for the concealment process, and then we conceal the characters using the random PRNG, and then formatting the identified location with the RGB color, and at the end we will get the what we call the stego text. The proposed RGB color used in this study is in range of 000 to 15, 15, 15. If you look, okay, on the right side, you can see at the top here in the first column, the value of 15, 15, 15 is a dark color. And then we go down, we change the RGB value to 15, 1, 1, meaning that you can see here the color still black. And also when you go look on the second column here, if the value of RGB color change to, example here, 15, 22, 22, and the color still black. But what happened? Okay, if the color you change to, example, 225, 255, 00, and then the color is red. So that's why, okay, why we use, okay, this value. Okay, the changes in the dark color are difficult to distinguish by human visual compared to the lighter color changes. Okay, so that's why we use the value in between 000 to 15, 15, 15. Okay, if you look, the RGB color exceeding 15, 15 will significantly cause the color palette to move away from the dark color, meaning that if you use the color example 255, 255 and 0 examples, you can see the table here. What is the color? Okay, so that's why why we use the RGB color from 0 to 000 to 15, 15, 15. Okay, when we check any values in between here, the color still dark. Now we go to analysis and result. Okay, in this study, we use English text as a medium for secret message for the cover text because different language will have different frequencies of the characters. Okay, before that, as we discussed before, we need to generate the homophonic table first. Okay, and that table is used to represent the secret message. Okay, example here, our message is meet you at 10. MEETYOUUATTEN. And then we can create various data representation. So in this case, I present C1. Okay, for the first representation, C2, C3, C4, C5, and C6. This value inside the table is referred to the homophonic tables. Example, M. Okay, if you refer to the homophonic tables, so you can get this value 503, or E 1968. Example, the same E here, the same character E, but we can have a different value. Okay, E here we have the value is 1968. E here we have the different value 81. So if you look another value here, example T, we have two T here, but they have the different value. This one the first representation. Same for the second representation. We can have M represent by 1284, E represent by 335, E, another E can represent by 104. So meaning that we can have various data representation by using the homophonic tables. So that's why we use the homophonic tables. So you can use any representation. You can use the C1 representation, C2, C3, or any. This is not limited to this one. So you can have more than this. Now we look how we represent the message. Okay, example here, if we refer to C2, okay, C2, the meet you at 10, the value represented by C2, M is character M, 1284, character E is 335, another E is 103, and so forth. Okay, until the last one, N, okay, 1953. So, and then this value, okay, this value for each character will be converted into what we call the 3D representation, or XYZ. How to convert this one? We use this formula. V equal to BX plus Y plus Z. Okay, this one is the formula here, whereby B is the value of B is the 15. Okay, 15 BX plus X plus Y. So and then you can get this value. Okay, X, Y, Z. So example here 335. If we use this formula to convert, we get 175. Okay, if 105, we use this formula, so we convert into 076, meaning that different value have a different value of X, Y, Z. Okay, based on the previous example, we use meet you at 10 as examples. Okay, now for this study, we use two experiments. Okay, experiment number 1 using the secret message arrived at February 27. Okay, where the number of character is 28 and we label as SMF1. And then the second secret message is the importance the important ocean amount of data have increased. Okay, we label as the SMF2, which the size of the message is 40 characters. So we label it as SMF1, 28, meaning 28 characters. SMF2 with 40, meaning 40 characters. And then we have run for 3 experiments here. Okay, E1, E2, and E3. Same like the previous one. Okay, for each character, so we can represent example here for the first experiment. We represent A with the 63, R 132, okay, and then another R 128, okay, and then same experiment number 2 using the same message arrived at February 27. So A now we represent 151, R 54, another R is 64, and so forth. Okay, this is how we represent. And then this line, okay, XYZ here show the representation in form of XYZ, meaning that 63 now we represent as 043, 132 represent as 085, and then 128 represent by 088. Okay, this how we represent the message, okay, using the XYZ. We have run for 3 experiments here. Okay, this is the location. Okay, the location where we store or we hide this character. Example here 63 we will hide at the location number 23, 132 we hide at location 50, okay, 128 we hide at location 110, and then 174 we hide at location 57, and so forth. Okay, although this one is the same, if you look here, E1 and E2 have the same secret message, but we hide in a different location. So this is the generated stereotypes. If you look here, the generated stereotype did not show any suspicious compared to the stereotype in the previous study. Okay, the stereotypes, the cover text is black color, and the stereotypes at the column here you see same like the cover text, meaning that there are no suspicious. And actually, okay, the stereotypes here hide the message, okay, arrive at 27 based at this location. Okay, compared to the previous study whereby, okay, the generated cover text is very colorful, meaning that it raised the suspicious. Okay, as a conclusion, okay, the objective of the study was achieved. It successfully hide the secret message using the method formatting cover text characters with RGB color and also the SQRT formula for multiple presentation. There are innovations here where we use the what we call the SQR formula in order to generate the 3D representation. And based on this formula, so a single secret message can have or can be generated can have a multiple representation. Okay, and then in the RGB color formatting for concealment, okay, we use the RGB color applied to format the characters, and strategy is hiding the secret message in the selected location. Okay, visualizing the RGB color application in the concealment information, and also this technique increase the hidden capacity compared to the previous one. Okay, the finding, hidden capacity increase compared to the prior studies, and then no suspicious because the generated stereotypes same, okay, same as the cover text. Okay, for the in future, okay, SQRT formula can be applied for the not only for text steganography, also can be applied to the image steganography, where image also use the RGB color to represent the pixel. Okay, so thank you for my presentation. See you next. Thank you.